Dr. Henry, while you're writing that, I have a quick question. Um, never mind. I'll just ask after. Never mind.
No, go ahead, ask now.
Okay. So in tutoring, I was asked like the polarity range. And I know it varies sometimes, but for polarity, what would be the range for something to be polar? Because I was asked this question and I didn't want to give them like a wrong range.
It varies between the text that you're currently looking at. So roughly, it is, so if you guys look at the area I gave you, in most cases, you guys are going to have a cut and dry. So if it's less than 0.6, it is considered to be nonpolar. If it's 0.6 and greater, up to 1.8, then that's considered to be polar.
Okay. All right. Thank you.
So if you look at another text will tell you it's 0.8. So it varies from text to text. So what I typically remember is the closer you are, because what you're really doing, you're trying to figure out, is it going to have a strong electronegativity, right? And so the closer you are to being a noble gas, typically you're going to be pretty strong. Now, if you meet somebody who's just as strong as you, right, then you're not going to be as strong. It's just think about life. So if you're going to fight somebody, right, and you fight somebody who's weaker than you, right, much weaker than you, who's going to win?
Me.
Yeah. Okay. So then if you fight somebody who's just as strong as you, who's going to win?
I don't know. It depends.
It depends, right? So chances are, if you don't like to get your butt kicked, are you going to fight somebody who's going to be weaker than you, the same as you, or stronger than you?
Weaker.
Okay. So you're going to fight somebody who's weaker than you, right? That's just the natural state of orders, right? So that's the same thing in terms of who's going to take that electron, who's going to pull it towards them. Or if there's a big difference, then that guy's just going to take the electron. If it's the same or about the same or close to the same, then they're going to share electrons, right? And so that's what you want to sit there and do. If there's a big gap between the two, he's going to want to pull it always to him, right? The guy who's strong is always going to pull stronger, right? So that's like you look at water and hydrogen. So conceptually, you want to think about the questions. And that's another thing that you guys you're very much, and it comes from our education, how we teach you guys younger. I'll take some of that responsibility because I'm teaching in this class. We have this much time to teach you this much stuff, right? And so we want you to understand concepts as well as understand the intricacies of the problem. You guys focus solely on the problem and you don't apply it to everything, right? So you need to get in the habit of applying it generally, right? We use miles per hour. Well, this is going to pertain to converting to the flow rates of water. It's not going to be anything different. You just need to apply that process to a different system. Do you understand what I'm saying?
Yes.
Sorry. I get started talking and I forget what I'm doing. Old age. Oops. Now, these aren't actual numbers, so if you go on Google Maps and just to quote me wrong, then more power to you. Okay, so here's the question. Now I'm going to put you guys in groups. Can you guys see your groups Have you guys, if I say breakout rooms, you guys have a little thing that says breakout rooms next to you?
No, I don't see it.
Okay, so I'm
I
gonna put
don't
you in
have.
group. I want you guys to get in groups, and those people who have a tendency of being quiet and letting everybody else do the work, you need to cut that shit out because you put yourself behind. You need to jump in there. You need to ask why. You need to be proactive. This is your education. Nobody else is going to get you that A in this class except you. So if you just sit back and let everybody else do the work, then you're setting yourself up for failure because you're not applying it. The part of allowing you guys to get together so you guys can discuss things and so you guys can kind of explain things to each other because I have this, I can't even explain it. I have a whole lot of education, right? And whether I like it or not, I try to get to the level that you guys are at and try to make it so that you guys can understand what I'm saying. But I've been doing this for a long time and I have my own ways and I'm old and I get cranky and all those things, right? Gray hairs. And like that old man that says, get off my yard, right? That's me right now, okay? So there's a tendency that you don't relate to me, right? And I don't relate to you. So maybe your peers are able to convey how to set it up. But if you don't ask and if you just nod, and that's what a lot of you guys are doing, you're just going through the process of nodding, because you're embarrassed to not know it. But damn, it's embarrassing to get that F when you could be getting that A if you take the time to sit there and interact with each other. And then those who understand it, take the time to help somebody else because the tables will be turned. And I guarantee you, they have often turned in this class. So they may pick up that information and they may be willing to help you. So if you take that little bit of time to try to help them out, it's always a good thing. You guys understand what I'm saying on that too?
Yeah.
Yes.
Yes.
Okay, so this is your question. Do you want me to put it in your chat box?
Please.
Yes.
Okay, I'm going to put you in groups because I wanted you guys to discuss it here because I want to hear you guys discuss it. But I'm going to make room trips around here and you discuss. So don't be paranoid. I'm just a stalker, that's all. Told you that in the very beginning. Okay, everybody got the question?
Yes.
Yes.
Okay,
Yeah.
let's see about this group thing. Yeah, you can type it out or you can draw it out.
So we took 24 miles and multiplied that to 1 hour over 75 miles, which got 32.32 hours for Kayla.
Okay.
And then we took 42 miles times 1 hour over 90 equals 0.46. So
Okay.
Kayla would arrive first.
So I'm writing on your screen right now. I'm going to keep it open. So you
Okay.
said 24 miles. One hour. So are you telling me, Matt, and I'm just curious, you're telling me that conversion that I gave you, that 75 miles per hour can be flipped over to meet my needs to get hours over here? Is that what you're telling me?
Yes.
Excellent. And why is this one 2 sig figs and not 1 sig fig?
because you started out with 2 sig figs and you're given.
And my equivalencies don't count, right?
Right.
Okay. Now, the important part is setting up this equation. Had I flipped it and I just used 90, let's flip this one since I have just wrote this one out, and made a mistake and wasn't paying attention to what I was doing or really following my units, and I put 90 miles per hour, is that going to give me the same answer? First off,
No.
no, it isn't. And what are going to be my units? Because here, these miles are going to cancel out. Miles over miles cancel out. Right? What would be the units in this case?
Miles per hour.
Miles squared?
Miles squared.
Miles per hour.
And then that immediately tells me
It's wrong.
that I did something wrong, right? So knowing that I got miles squared per hour when I was just looking for hours should be a big flashing red light saying, you did something wrong, you did something wrong, you did something wrong. You know? So do you guys understand why it's important to follow those units?
Yeah.
Yeah.
And look back at your test, right? Your grades, hopefully I'll finish them all up tonight and you'll see them tomorrow. But when you look back at your test, look how many of you guys did exactly that, where you switch those units.
I don't know how to do it.
What was that?
I don't know how to do it. I failed totally.
Well, and don't go jumping off the bridge because you failed, okay?
No, I won't. You know.
This is going to be a rough semester because one thing, we're doing it all online, and that is a challenge. Let me tell you, I feel like I'm working 50 times harder than I've ever worked for a class in my entire life, right? Do you guys feel that way?
Yeah.
Yeah.
And normally, as students, you guys are going to, in my class, you work 25 times harder than you normally do. So you're doubling that, right? So it's pretty intense trying to do everything online, and especially stuff like this because, you know,
That's right.
a lot of it isn't intuitive, but sometimes it is a little bit if we sit there and take a moment to think. And I know it seemed 2 hours seemed like it was very, very short, right? But overall, did you guys feel like you had enough time for the exam?
No,
Yeah.
I waste my
Yeah.
time. That's why I don't have enough.
Yeah.
The
You
only
didn't have
thing-
enough? What was that?
I was gonna say the only thing was that one question where you had to press tab. I couldn't get out of it for a little while, and I was like starting to freak out.
Yeah.
Yeah.
I
I'm
couldn't
here.
figure out how to zoom it like back to the questions. It was all
Yeah.
off to the side.
Yeah, I can't explain why it did what it did, but it did what it did, right? And you know, it's like I could have one question that will work perfect, and then I'll have 2 questions that worked bad. And I even had trouble with the very last question on some people's exam. It locked in an answer, right? Even though that, and I tested it out because it did it to me. It locked in an answer, even though I didn't select that answer. And so I was
Oh,
like,
wow.
okay. So
That's
yeah,
weird.
it was a little bit of a challenge, you know, and so we're gonna have some technical difficulties. I apologize. We're working out the kinks. Yeah, Canvas was not, it seems like it wasn't designed for courses like ours, like math courses and chemistry courses. It was more designed for like their exam sections, more designed for like history or, you know, where you're just writing answers and stuff like that. It's a lot harder to sit there and do what we do there. So bear with us. We'll try to get those kinks worked out or find better solutions. It's a process, and I apologize, but you know, I'll do my best. So I wanted to make reference to this because, you know, this is whether you recognize it or not, this is going to be your bread and butter of chemistry when we get down to start solving these equations, setting up these equivalencies and tracking those units. If you get this down now, you're going to be golden later on. I guarantee it, right? So if you don't feel that you have a good grasp on this, you want to bombard Jessica on it, okay? And also think conceptually, right? And you guys know what I mean by conceptually?
No.
No? Okay, for instance, oops. Oh, Matt, sorry. I was writing on your screen and you closed it on me.
Oh, I'm sorry.
That's all right. It's evil. Gosh.
Usually people are telling me to stop sharing, so I.
Okay. Let's see. So let's say, for instance, right? There's a relationship between picking fruit and people, right? So let's say for every one person, they pick 25 apples. Now, if I sit there and I say, on the average, one person picks 25 apples, right? And usually we're going to associate it with time or something like that, right? So if we can sit there and say there's an equivalency between, on an average, one person can pick 25 apples, right? Is there a way that I can make this equivalency equal? I'm saying right now, this here means proportional. Is there any way that I can actually make it so that these guys are going to be equal to each
No.
other?
You multiply?
No.
No? Okay, so let me give you another example. Let's say mass is proportional to volume. Is there any way that I can make these guys equal?
Yes.
Okay. If I have energy is proportional to frequency, is there any way that I can make these guys equal? Or, yeah. Or sorry, energy is proportional to
Wavelength.
1 over wavelength. Sorry.
Yeah.
What do you
Okay.
mean by make them equal?
So that it'll actually be equal, because proportional, this here means as this goes up, but there's no
Yeah.
way of actually saying this amount of energy requires this amount of wavelength. Do you know what I'm saying?
Yeah.
Okay. So conceptually, what about this guy? Is there any way that I can make that equal? Energy is equal to frequency.
No.
Yes.
Okay. So we'll do a poll here, right? So let's start off with the very first one. See if I can type with my poll. Hold on. Poll. Where you at?
What do you think?
So what do we have? Let's talk about this right now, and then I'll put up the next one. So in this case, So do we have an equation where mass is equal to volume? Or some way that we can make mass equal to volume?
The density?
Density.
Equals volume?
Density equals mass over volume. So this here is the perfect example. So VD, density, I told you guys, is a constant, as long as it's at the same temperature. So this is basically putting a constant that allowed this proportionality to work out. So if we put a constant here, so our constant in this case is D, then we allow it to be equal. So big picture is, when you see relationships between things, right, you can sit there and if you get consistently the same results from it, that same proportionality results, you can sit there and make them equal by introducing a constant. So this guy here, where we have one person is approximately equal to 25 apples. You can't do that necessarily, because is that a constant? Are we guaranteed that every person is going to pick 25 apples?
No.
Right? So in that case, we can't make an equivalency. So this proportionality doesn't hold true, where this one will hold true. So the density of a metal, we're talking about the density and volume of a metal, or the density of a gas, or the density, they're always going to be exactly the same, regardless. So if you have 8 pounds of gas, well, the volume of that 8 pounds of gas is going to go up at a consistent number, right? And so they're going to be consistently related to each other. So therefore, we can use a constant, right? So if I have 4 pounds of gas, it's going to go lower than that 8 pounds of gas by the same number. So you're going to keep that same ratio. So the fact is that mass over volume is going to equal that density. So if I have, for instance, so the density of water is 1 gram per milliliter. Okay, that's a constant. That's always given. So if I have 50 grams of water, how many milliliters of water will I have?
50.
If I have 100 grams of water, how many milliliters will I have?
100.
100.
If I have 1,000,000 grams of water, how many milliliters will I have?
1,000,000.
A million.
Okay, so that ratio is always going to be the same, right? It's going to be that 1-to-1 ratio. And so that's what I'm saying. So we are able to sit there and set things equal by having that constant, right? So for instance, let's see, I think it's 0.820. I think this is the density for grams per milliliter for gasoline. Okay, so whether I have 100 grams of gasoline or 1,000 grams of gasoline, this ratio is always going to be the same. It's always going to end up being that same density. Do you understand?
Yes.
Okay, so that's setting out proportionals. You're letting that proportion equal a value. So we started out with a proportion. The proportion is mass to volume. By us and putting that density in there, we're able to say equal. Do you guys get the difference? Big picture. Right now, we're just saying they both go up. As mass goes up, volume goes up. If mass goes down, volume goes down. This one tells us exactly how much it goes down by. Do you understand? Okay, so proportionality allows us just to say something very general. Big picture. Goes up, goes up. Goes down, goes down. Okay, for instance, here, this is actually a true statement. Energy is proportional to 1/lambda. Right? Because we know that, let's see, C equals lambda nu, right? And so C over lambda equals nu. And we know that E and nu are proportional, so I could substitute this guy into here, and then I get E is proportional to 1 over lambda, right? Or I could say C, but we know C is a constant over lambda, right? So you're just saying it's proportional to a constant. So we're just throwing that constant in here in that proportionality. So as energy goes up, what would I expect lambda to do?
Down.
Go down, right? And this says that they're indirectly proportional, meaning one goes up, the other one goes down. The way you always know that is because one will be like a normal thing and one will be 1 over that value, okay? So that means indirectly proportional. So if I have 100 joules, I would expect my lambda to be a small value compared to if I have 1 joule, what would I expect my lambda to be? Would it go up or down?
Up.
It would go up. So as my energy increases, my lambda should go down. As my energy decreases, my lambda should go up. You guys see that?
Yep.
Yeah.
Okay. So proportionalities are going to play a huge part in chemistry. So you want to understand that concept. And I saw that there are about 4 or 5 questions that popped up that a lot of you guys struggled with dealing with it. And so you guys were taking things so literally that you thought, oh my God, I didn't know this equation. But if you read the question, it was basically telling you it was a proportionality, or it was saying that, you know, you could set up equations saying that these guys are equal based upon what was stated in the question. Okay, so sometimes take a minute to read the questions. I set out each of the questions, you had about 2 minutes. You know, it shouldn't take you 2 minutes. A lot of them are really short questions, but if you looked at them and you just thought about them for a minute, you know, 1 minute of those 2 minutes, you'd have recognized, oh yeah, this is what they're talking about. Think big picture, you know, especially when it's stuff that you may not be familiar with, or that, you know, we didn't go specifically over this by detail. Think big picture, okay? And that is one of the things that most students struggle with. Wouldn't you agree, Jessica?
Yes, I agree.
Yeah, because you're so used to it, you've gotten to the point where my teacher gives me this equation. This is the equation I'm going to use, right? That you're not thinking about it. And what we need you to do is kind of open up your mind. You need to be a little bit of flexibility going on. We need you to open up that mind, open it up a little bit, let some more stuff come in, okay?